So, have you ever really wondered what's going on inside an AI's mind? I mean, not just what it does, but how it actually makes a choice, how it decides what's important and what's not? Well, we're going to dive right into that, because a fascinating new paper is suggesting a totally radical new way to think about building them.
For decades, we've pretty much built AI on one simple idea: chase the reward, get the high score. But this new framework, it suggests there's a much smarter way to go about it. One that moves beyond just racking up points and gets us to something that looks a whole lot more like genuine intelligence.
And this really frames the whole conversation perfectly. On the left, you've got the old way, an AI that's just trying to maximize a single number, a reward. It works, for sure, but a lot of the time it's a total black box. But the new way, over on the right, that's about achieving very specific goals while also respecting hard rules and constraints. It's about planning, not just blindly reacting.
Okay, so to get our heads around this, here's how we're going to break it down. First, we'll talk about the problem, what I'm calling the reward trap. Then we'll explore this new blueprint for planning, see how it can actually predict the future, and how it builds complex plans. After that, we get to the really mind-bending part, how it understands value. And finally, we'll see why this all leads to AI that's way safer and more trustworthy.
Right. Let's kick things off with the big idea that has dominated artificial intelligence for, like, half a century. This whole reward trap thing. The real question is getting the highest score really the same thing as being intelligent?
This right here is the reward hypothesis. It's the core belief that you can get an AI to do basically anything, from mastering chess to driving a car, just by telling it to make a single number go up. More points equals a better AI. It's simple, it's elegant, and for a very long time, it was unbelievably powerful.
But, and this is a huge but, here's the catch. The paper argues that when you get to really complex, dynamic worlds, think of a huge video game with tons of different systems all interacting. This simple idea actually starts to hold us back. A single high score just isn't enough information to navigate a world that has subtle goals and, hard limits you can't cross.
To make this super concrete, the paper gives us the perfect example. A little agent they called the honey badger. Its job isn't just get points. No, it has this multi-step quest with a bunch of interconnected parts. It needs to find items, it's got to get a key. But what's really crucial here is that it has to manage its own internal state, like how thirsty it is. See, dying of thirst isn't just losing a few points. It's game over. It's a hard failure. A simple reward signal just can't juggle all that complexity.
So, if points aren't the answer, what is? Well, this brings us to the very heart of this new idea. A totally new blueprint for AI planning that thinks in terms of goals, not just scores.
Okay, it's called a Task Markov Decision Process, or TMDP. Now, don't worry about the fancy name. A Markov Decision Process is just the classic math for describing a decision-making problem. What's new here, the TMDP, is, well, it's like a smarter instruction manual for the AI. Instead of just one single reward number, it gives the AI two totally separate channels of information. First, you've got the goal function, which is basically asking, hey, what's the probability you actually achieve the thing you want? And second, there's the constraint function, which is asking, what's the chance you mess up and break a rule you absolutely, positively cannot break? Like our badger dying of thirst. And that separation, that's the game changer right there. It's everything.
Now with this new instruction manual, the AI can do something truly amazing. It can actually look into the future and map out all the possibilities. It basically gets its own crystal ball.
This crystal ball has a technical name, of course, the State Time Option Kernel, or STOK. But seriously, just think of it as a predictive map. Because the AI has that new two-channel instruction manual, it can now generate a super detailed forecast for any plan it thinks of. It doesn't just say success or fail. It predicts the probability that you will end up in a specific place, at a specific time, having achieved your goal or not. It's so much richer.
So let's jump back to our honey badger for a second. A really critical question for it at any moment is, from where I'm standing right now, is it even possible for me to get to the water before my hydration hits zero?
And this map shows off the incredible new power the AI has. It can generate a complete possibility map for its entire world. So on this map, every yellow spot means, yep, from here I can totally make it to the water safely. But every blue spot means, nope, no way. From here it's impossible, I'm going to violate that hydration constraint. It can see its own limits before it even takes a single step. And this ability to see the future of simple plans is what unlocks the next huge idea.
So being able to predict the future of these simple plans opens the door to another really powerful idea.
building complex intelligence out of simple, reusable parts. It's like snapping together Lego bricks.
In the world of AI, these little building blocks are called options. And you can just think of an option as a learned skill, like a little mini program for achieving a small goal, like go find the nearest door. It's a totally self-contained skill that knows what to do, that's its policy, and it knows when it's finished, that's its termination function.
And now, we get to see how this builds up into a much bigger plan. Instead of having to figure out every single footstep from scratch, the AI can now think at a much higher level. It can put together a complex plan just by stringing these options together. First, run the getKey program. When that's done, okay, now run the getItem program, and so on. It's building a real strategy out of skills it already has in its toolbox.
This leads us to what is, for my money, the most fascinating and maybe the most important idea in this entire paper. How does an AI figure out that something is valuable if it doesn't give you an immediate reward? I mean, what makes a key really worth picking up? So here's the crucial question. Under the old reward model, a key is basically worthless, right up until the exact moment you use it to open a door and finally get some points. The AI has absolutely no reason to pick it up before then. But we all know that's not how real intelligence works. That key has an intrinsic value. The question is, how can an AI possibly understand that?
The answer is a concept so powerful it almost feels like a philosophical shift. It's called empowerment. Empowerment isn't a reward that the world gives you, it's a value the AI calculates for itself. It's like an internal curiosity, an internal drive. It measures how much control an agent has over its own future. The value of an object, like that key, isn't about the points it gives you, but about how many new doors, both literally and figuratively, it opens up.
This just shows it perfectly. Without the key, our badger is stuck. The set of possible futures it can reach is really small. Its empowerment is low. But the instant it picks up that key, its world just expands. Suddenly, all those goals on the other side of the door, they're now possible. Its empowerment skyrockets. The key is valuable because it gives the agent freedom and more influence over its world.
So, what does all of this add up to? Well, beyond just being a clever new way for an AI to plan, this whole framework gives us a path toward building AI systems that are not just smarter, but that we can actually understand and, more importantly, trust.
What this approach gives us is an AI that's compositional and modular, one that can build and reuse skills. It's interpretable because we can literally ask it, hey, why did you pick that plan? And it can show us the possibility map that proves it's going to work. And maybe most importantly, it's verifiable. We can mathematically prove that an agent will respect its constraints, that our honey badger will not die of thirst. That is a massive step forward for AI safety.
This quote from the paper it really reframes what we even mean by an agent. It's not just a system that chases points anymore. It's a system that can actually understand why something is useful, why a key is significant, in relation to its own goals and what it can do, and then use that understanding as a reason to act.
And that leaves us with one final, really deep question to think about. By moving beyond these simple external rewards that we define, we're creating agents that can find value from within themselves, agents that are motivated by their own ability to influence the world around them. So if an AI can understand value on its own terms, what will it eventually decide is truly important?